Hey guys, this is I guess tutorial number 3, but it didn't matter, it's not in order. So I'm just making a random tutorial on some diagram. So this is the paper for Advanced 2023, paper 1, and as I was going through the paper, I had to draw some diagrams. So I thought let's record and put it on YouTube. So uh, it's question number 3, and we have this electrical circuit kind of thing. So we are going to make this drawing in this tutorial. So let's get started. So firstly, I think you should know already, you have to use the package called circuit Tikz, and that's it. Only circuit Tikz like package. So Copilot is giving some suggestion about the drawing, so let's accept and run it. So no, Copilot thing is not great for the drawing, as I already told you. So I don't know where it is wrong, but somewhere it's wrong, and I think yeah, here it's wrong, and now it will be fine, I guess. Should be fine. No, should I be fine? But don't worry. Let's run this. No, what's happening? So sometimes it happens, not often, but sometimes yeah, it happens. Whenever you try to like run multiple times, it gets stuck. So let's delete this PDF, and then we can run, then it will be fine, I guess. So let's delete this, and let's run this again one more time, and let's open it here. So yeah, as you can see, it actually run a diagram, but it is not great. It looks kind of funny. It is not great. So let's start from a scratch. Sometimes it helps, but most of the time it isn't. It is like good for solution thing, typing thing, all. Or Copilot helps mostly in Python or other languages when you're calling API or kind of traditional thing, not especially designed for them. Takes, or you can say there is not a lot of data on Tikz, so that's why it may not provide you with a better solution. So let's cut the chase and start. So firstly, we have to define few coordinates. Again, it's a good idea. It's not necessary to define coordinate, but generally it's a good idea to define coordinates. Then after you can proceed accordingly. So let's define few coordinates. So I'm gonna use TZ coordinate, as you already know now. So 0, 0, and let's call it O, which is origin, and thereafter from origin we can proceed. So first thing, as you can see, there is a capacitor and then a resistor. I'm drawing from lower end, then upper end, then upper end, like that. So first part is, let's zoom in a little bit. Yeah, so as you can see, first circuit is a capacitor. So we can say from O to, so refer O to, and then you can see capital C for capacitor, and then we can label thing as well. So label will be like this inside the dollar sign, and let's see 2 microfarad. So 2 microfarad, I don't think I have named this, but let's continue with this. And double plus means, as you already know, we are using relative coordinate system, so we move 2 unit towards right, and then we can stop here. So after running half, we will see here. So you can see it is a capacitor, but as you can see, labeling is in the upper part. It doesn't matter, we can put underscore to lower it down, but I think in the original diagram as well it's in upper part, so let's keep it that way. And one more thing I'm focusing here, that the size of capacitor is kind of large, so we can change later on at the same time. So for right now, just focus on the drawing part. And again, this is a capacitor, and then from that we want a resistor towards right. So for the resistor, we can again add 2, then R stands for resistor, that's why we're using R, and 3 ohm. I think it's giving a better suggestion, 3 ohm. Then plus 2,0, it's fine. By the way, you can accept selected word by command and then right arrow key. So as you can see, it's a 3 ohm resistor. It totally fine. Again, you can see resistor is kind of quite large, but we can change the size for the whole element thing at the end of this video. So let's proceed again. And one more thing I'm saying is stem length is quite small. We can define a length here that will help define. It's like stem length, SL, stem length. So let's call it or a stem length or element length. Let's say element length. Element length, say let's say 5 right now. That will be better. So instead of 2, we can just not 5. Let's say 3. Instead of hard coding the proper value, just let's reference EL. So if we want to change later on, we can change just the definition of EL part, and then we will get the whole like diagram changed automatically. So referencing variable is a good habit. And let's move on to the upper half, and from there again we can move to, and we can use sort actually, or if you don't want to use sort, we can just use 2 and that will do the job. So for right now, let's use sort, and that will be better. And then we can just use plus 0 for the x coordinate and y. So we can use element distance. Again, we can define another coordinate, but I think let's define. So circuit gap, element gap, let's say element gap. So element gap, we can keep it as 1 unit, and that will be better. So element gap, and after saving, you will see a this is how you can. And let's remove this part for right now. So as you can see, there is an element gap, and we can change this element gap and element length later on. So now again there is a resistor towards left, and so let's continue making this diagram, that will be better. So you can use 2 and resistor, capital R for resistor, leveling tail, again we can use the suggestion here, and again here we can change 3 ohm and plus, and then now we have to move towards left, that's why we can move towards EL0, and yeah, it's fine. So after same, you can see, but as you can see, level is downward here because we are moving anti-clockwise direction, that's why we have to put underscore here to get the level upward here. It's fine, and I think we can sort this circuit. So 2 we can sort, and again plus 2 and minus element length comma 0, yeah, it's fine. And as you can see, there is a current in the second part, so we can use current, or let's say I is equals to, I don't know exactly how to put the current arrow. I've done in the past, but I have no, yeah, I think it's working, I guess. So yeah, current, but arrow thing is not working. And let's go to documentation. I think what I have done in the past, I don't know exactly where I've done, but let's ask GPT. So arrow for current direction. Want to do, yeah, it will check automatically and do the job. It's got good at that. Yeah, I think I have never thought about this, but let's try. I don't think it will work. No, it's not working. It's just hallucinating. Yeah, Copilot does most often uh, about the things which it didn't know. So let's go to the documentation and you can search. Where is the documentation? I don't know. Yeah. So this is the documentation. You can search for the current and arrow thing. By the way, you should read the documentation thoroughly. It's not like you have to read like textbook, but just go through it like casually. You can check out some element or whatever you need. It's a good habit. So where should I look for current? By the way, I was talking about the size of the element. I can use this Tikz set and we can define the size for the elements and we can change that. Where should I look for current? I should mark something. Yeah, you can see F. I don't know what F stands for, but current is, or you can say I is equals to I naught. But yeah, we have to use American circuit, and this is what wrong going on in our circuit. So it is European circuit. In that the arrow thing is outside the circuit actually, and in the same circuit if we want to put the arrow thing we have to use American circuit. So yeah, you can copy this part American and you can use it like this. Let's save and then see what happens. Nothing. I think I have to use inside I don't know exactly where should I use circuit is. I have to use in the preamble, I guess. Use package, but I don't have the preamble. I have like custom package. Should I use? Yeah, if you want to use, you can load the package like this, and that will do the job. Should I use like this? Yes, let's copy, but it will break other parts. I don't know. Should I? Oh. Let's say no scale to. I wanna do like. I don't wanna do this like so. Right now, let's see the customization which we were talking about. So as you can see, for the customization, we can change length, we can change bipole length, we can change even size, as you can see. So yeah, for the resistors we can change size. So let's try to do things. So see Tikz. So let's copy this part. By the way, you can do this for the whole document or kind of a specific, doesn't matter. No, we have to use style set to registers. So registers styles big R bipoles. I have done in the past, but it is suggesting some other bipoles thickness. Yeah, so let's copy this, not height. So let's copy this part. So let's save. So as you can see, no, resistor size is not changing. No. Let's go to, where should I go? Nothing. Where should I go? File. Okay, so let's go to overleaf. I have done a tutorial a few days ago. So as you can see, we can, yeah, oh man, it was pretty simple. I was messing things up. So actually you don't have to remember all these things. It's called bullshit. So batteries, we can add resistor or anything. So for right now, let's add resistor or capacitor, capacitors, and a scale 0.8. So as you can see, capacitors has got a smaller, and we can add resistor as well. Let's try to add a resistor, resistors, but I don't think it will work like this. No, so I think let's put in curly braces grouping things, may work. So add, no, it won't work either. So I guess I have to like put manually things. So again, a scale is equals to 0.8, and then we can put comma. That will be better, I guess. So no, still not working. Why? We have to like, I don't know what's happening here, but I have tried like this. I have to add manually for each. That is not good. Resistor. Let's right now just keep it that way, manual thing. But I think I have done in the past. See, takes it. I done in the past. It works like resistors. No, it is not working. It's weird. Don't know what is happening. It is not working. Let's save it. Yeah, it's working for the capacitor and not for the resistor. And what if we just put, what if we just resistors? No, that means somewhere there is a spelling mistake. It's not like we are doing it wrong, but somewhere there is a spelling. Resistors. Oh, spelling TORS. Sorry. Yeah, so it's working, but one more thing I was about to test, resistor as well as capacitors. No, again it's not working, and previously it was. Oh, that means we have to do manually. Yeah, I get it. Yeah, so it will work now. Yeah, so for both we have to add separate lines. That will be fine, and we can add a manual like battery thing as well. So it's fine, I guess. And sorry, let's move on to main part. we were like drawing this current arrow thing. So if we want to like change in the circuit the arrow thing, we can use actually the package loading inside the package. That will be great, but I don't think I want to do that. So let's search for something current. I can do. This is not source. I wanna current. What I have to do this American. Let's copy. Let's try to set this by here, like Tikz set. So set, and then put American. Maybe it will do the job. American inductors, not American current. Let's add. So no, it's not affecting. But let's go through some. Where should I go? I have made this actually circuit, and I know clearly that where should I look for, like let's see in the paper 1, paper 2 maybe. I made this circuit. Some of you may think about like why I do this in the tutorial. Why not I just do the research before the tutorial, and then we can just put it right there. Actually, I want to make it raw. It's not like refined, cut it out in the video and you see the refined version and you think like I just know all these things. No, I don't know. It's like whenever I try to draw all these diagrams, I have to go through manuals and I have to Google search and all that. As you can see, this is not the way I was thinking. So yeah, I have to look for documentation and search Google at the moment of making. It's not like you have to memorize everything. No, that's not a good idea. Yeah, sometimes you will get the idea, but most of the time you will just won't. It's like, yeah, after making few papers you will, but the thing which is not in daily use you will just forget. So it's better to just learn how the real work is done. Just get comfortable with that. Okay, so what was the no. Yeah, this is the actual paper actually, and let's open this is the Instagram, but let's open. Oh man, I did wrong. Let's delete all this. Yeah, so this is the main paper actually. And let's zoom in a bit. So question number 9, yeah, 25 was the, yeah, so this is 30, 29, 20, 27. 27, so digital line cost. Where I'm looking at, I don't know. Yeah, I'm looking at the right thing. A charge particle. Yeah, charge particle. Yeah. Oh, that means we have this S diagram. Battery. Everything is correct. Yeah. Build it like this for the current. Let's copy for it now and see what happens. So delete this part, and for current we can just put this and delete also the arrow thing. Let's save and See what happens. Yeah, it is working, as you can see. So yeah, sometimes we have to search, experiment. Yeah, so it's working now. And not 2 ampere, it's just I1. So I underscore 1. And even as you can see, I didn't set the American or European type of circuit. So yeah, sometimes package bugs like weird. So okay, let's move on to next part. Again, we have to sort thing. I think most of the time you don't need to pass full tutorials. Like you just have to get the idea what I'm trying to do, and then you have to like apply in your own diagram or whatever you're trying to make. That will be much better. So now you can see the diagram is getting complex, so we can actually make this diagram part by part, and then after we can just join this part. So it depends on you actually. It's not like mandatory to make all this. So for simplifying this diagram, I'm gonna make one more coordinate which is called, or which will be like 2 times sorry, EL, element length, and will be 0, and let's call it O dash. So let's define all these segment above. That's how we can reference this in the other commands. So again, we defined O like this, O dash like this. So I did it because we want to break the element to get easily. So for, I don't want to sort this thing. Yeah, we can obviously sort this thing, but I don't want to sort this thing. So we can just remove all this part, or do I want to remove? Let's remove, the matter. And again, draw, and this time we want to O dash, and O dash to now O dash is like here, so we have to move upward. So we have to calculate here. This is the interesting part. So we have to calculate the coordinate. So 0 comma we want upward, so that's why we have to use EG. That means key element gap. And after putting this part, as you can see, it will be quite fine. And if you run this code, you will see exactly the same except this part. Yeah, so again, we're gonna remove this sort thing. So yeah, as you can see, in one line of command we have exactly like one circuit, not the whole like chain thing that will just mess up the full command. So yeah, that's fine. And again, we can draw the upper circuit, and now you have two choices if you want to draw from the left to right or right to left. So I want to make like left to right. That is much easier to think in the mind. So draw, again we have to calculate the coordinate. That means we want from like O to 2 unit upward. So O plus 0 comma 2 times element gap, and so this coordinate will be like here. And then after we can just move towards, so 2, and then we can use battery, and battery 1, and voltage is 5, right? So 5 volt, and then we can plus, then we can use element length 0, then we can save this part. So as you can see, but as you know, battery is inverted, so we can add invert, and this is how you can invert the battery. So as you can see, invert the battery, and again you can see battery length is kind of large, so again we can see it is and set, and battery just scale 0.8. So yeah, now a small battery, and again from there we want like resistors. So capital R resistor, and we can use the level thing is equals to 1 ohm, so 1 omega and again we can add element length, and it will be 0. So it will say yeah, this is the resistor. And again we can draw the other elements in the similar fashion, which is one element left. So either we can copy this part exactly like so, that will be much easier. So one more thing I have to do, I just have to replace this part 2 times. No, we want 3 unit of board, and again cell will be remain same. So instead of 5 we have to use 15, and resistor we have to just use R, not the omega, nothing, just R, and it will be fine, I guess. Yeah, yeah, it's fine. We can increase the gapping, and that will do the job. So element gap, let's put 1.25, that will increase the gap. So yeah, element gap is 1.5, and we can decrease the size of the element, that will help too. Let's say 0.7. 0.7 is quite okay in size, so 0.7 will be fine. Yeah, now it's fine. So as you can see, most of the circuit part is done, just we have to join the line. That is why I wanna make this way. So for now, just you can either use draw or just short circuit. Draw from O to, or we have to add a key actually between O and 2. Actually don't know how to add key. I think I had some library reference here. Key or switches and button. So yeah, you can add any kind of switches, as you can see. No shape NOS we can add. So NOS plus in X direction we just do upward, right? So we have to use element gap, right? And this should work fine, I guess. So yeah, as you can see, it's an open switch and working fine. And now we can sort even more thing. So we have to calculate O dash to we can sort, or just you can draw line, doesn't matter actually. So we can sort all the elements in a single line, element gap. It's actually right side. So as you can see, all the gaps is sorted. And one more thing I have to do is draw from O2. Again we have to sort. No, we have to actually use the coordinate calculation thing. So coordinate calculation works like, as you all know, I will explain in the earlier videos as well. So we have to move towards the board element gap, and this is actually calculating two coordinates, O plus this. That means we are starting from here, move to here, calculate the coordinate, and sort. Again we can sort. So yeah, as you can see, element is sorted now and the key is open. So yeah, our diagram is done, and we can put label for the key, which is called capital K. So yeah, K towards left, and if you want right, you can just add underscore. So diagram is done. And a few more things I want to explain here. If you want like dot, as you can see, as you see in most of the books, that every element. So let's try to add this in 15 volts. So what I'm trying to say will get in a few seconds. So if we add a star dash star, that means it will just draw two dots at the one at the beginning of the element and one at the end of the element. So yeah, you can manipulate like this. So I don't want dot actually, it looks perfectly fine in the normal way. So I like this way. So I guess this diagram is done, and hopefully you have learned something important here. and all is practice. So continue making cool diagrams in physics and you will enjoy making after all. So yeah, this is done, and from this tutorial I will just add the PDF, or you can say source code as well, in the description, so that you can just copy and enjoy the code. Thank you, and see you in the next tutorial. I have